Hi students, in last video, what is the specific heat? Why the different materials having different specific heat is completed. So in this video, we want to derive an expression for specific heat experimentally. So for this purpose, we are taking same volume of same material of two beakers. Same volume, same material of the two beakers. So like this is the A beaker and this one is the B beaker. In A beaker we are taking 250 grams of water. In B beaker we are taking 1 kg mass of the water. And we measure the initial temperature of the water in both beakers. We note the initial temperature. Now we are by using a Bunsen burner. For example, Bunsen burner, we give the heat to these two beakers till they rise the same temperature difference. Means, for example, the temperature difference 60 degrees centigrade we want get. So when we give the heat continuously to this both beakers till the temperature difference reaches to 60 degrees centigrade. In this case, we calculate what is the time taken to A beaker, what is the time taken to B beaker of the water to get the temperature difference is 60 degrees centigrade. TA is the time taken to the water of A beaker. TB is the time taken to the water in B beaker. We observe that TB is greater than TA. Here the water in B beaker takes more time than A beaker because of its mass is more than A. Here time is increases means the amount of heat transferred to B beaker is more than the amount of heat transferred to the water in A beaker. So the amount of heat given to water in A beaker QA, the amount of heat given to a B beaker is equal to QB. So QB is greater than QA. Why the amount of heat is more required for a water of in B beaker? Its mass is more. So we know very well MB is greater than MA. Due to this one, QB is greater than QA. So from this explanation, we say that to get the same temperature difference of any two substances of same material, less mass of the substance require the less amount of heat, more mass of the substance is required the more amount of heat. So from this explanation, we can return that Q is proportional to M. Q is proportional to M. This is equation number 1. Now we are doing another activity. Simple thing, nothing but we take the one vessel or one beaker we are taking. In this beaker, simply we are taking the 1 liter water. 1 liter water. We are giving heat continuously for every 2 minutes. For example, every 2 minutes, we are measuring what is the change in temperature. What is the change in temperature? The time is increases, the change in temperature also increases. Time is increases, the change in temperature also increases. For example, initially it's have a 30 degree centigrade. After 2 minutes, 40 degree centigrade. Again after 2 minutes, 50 degree centigrade. So in this manner, time is going on, the temperature is increases. The change in temperature is increases. So time is increases means the amount of heat given to this beaker is increases. So the amount of heat given to this beaker is increases. Relatedly, what happened? The temperature difference also increases. The temperature difference also increases with respect to initial temperature. So Q is directly proportional to delta T. This is equation number 2. From this 1 and 2, what you can write? Q is proportional to M into delta T, or Q is equal to S into M into delta T. Here this S is taken as a proportional constant. This proportional constant is called as a specific heat. So in this equation, S is taken as a constant. This constant is called as a specific heat. This constant is called as a specific heat. Okay, so overall, from this experiment, what we find? The amount of heat given to any substance at constant temperature difference directly proportional to its mass, and the amount of heat given to any substance at constant mass directly proportional to change in temperature. Okay, so from above explanation, Q is equal to S into M into delta T. S is equal to, we can written as Q by M into delta T. In this, if M is equal to 1 gram, for example, temperature difference is equal to 1 degree centigrade. Then from above equation, what you can write? S is equal to Q. Means unit mass of the substance, temperature rises to 1 degree centigrade, the amount of heat required is called as a specific heat. Unit mass of the substance, temperature rises to 1 unit temperature, the amount of heat required is called as a specific heat. Nothing but this is the definition of specific heat, which we discussed in last class. Now, units in CJ system, the units for specific heat in CJ system, calorie per gram degree centigrade. In SI system, joule per kg Kelvin. Joule per kg Kelvin. At the same way, you know very well, 1 calorie is equal to 4.186 joules. Now, the relation between the CJ system and SA system of specific heat can be written as calorie per gram degree centigrade is equal to 4.186. 1 calorie is equal to how much? 4.186 joule by 1 gram can be written as 10 to the power of minus kg. At the same way, in Celsius thermometer and Kelvin thermometer calibration, you know very well. In Celsius thermometer, lowest fixed point, upper fixed point, we have the 100 divisions. In the same way, in Kelvin thermometer, lowest fixed point to 100, upper fixed point, 100 divisions is there. So here 100 divisions, Celsius in 100 divisions, Kelvin also in 100 divisions. But lowest and upper fixed points are 0 and 100 and 273 to 373. That is the different. Okay. But 100 divisions of Celsius thermometer is equal to 100 divisions of Kelvin thermometer. That's why we can written as 1 Celsius is equal to 1 Kelvin. Okay. 1 Celsius is equal to 1 Kelvin. So what you can write? 10 to the power of minus 3 kg 1 degree centigrade also we can written as Kelvin. Simply, what is the value? 4.186 into 10 cube joule per kg Kelvin. This is the relation between the calorie gram degree centigrade to joule kg Kelvin. Calorie gram degree centigrade to joule kg Kelvin. So 1 calorie per gram degree centigrade is equal to 4.186 into 10 cube joule per kg Kelvin. This is the expression for the specific heat. So specific heat is depending upon the amount of heat given to the substance, mass of the substance, and temperature of the substance. Okay. In next class, what is the principle of method of mixture and the mathematical expression for resultant temperature in the case of after the mixing of the substances. Thank you.